And I'll dance with you in Vienna. That's just the line from Leonard Cohen's Take This Waltz. And I think that conferences actually are a way of dancing. We're making things together and exchanging experiences. I couldn't help, I had to do it. Gentle ladies, gentlemen, and gentle everyone. My name is Lars Hjalmert. I'm a member of the International Advisory Board, and I'm here to sort of chair this keynote, although I've never heard of anyone chairing a keynote before, but this is what I have to do today. So I actually am going to introduce Elisabeth Pollitzer to you, and after she has given her keynote speak, I think we have some time for questions and comments and those things. But I give you the background to this keynote. I won't introduce Elisabeth with giving her credentials because they are in paper and you can see them. So I just give a background to her speech. And actually, another professor, Teresa Ries, was supposed to share this keynote with Elisabeth. But Teresa went ill for about a month ago and couldn't attend this meeting. So I'm suggesting actually to Brigitte that we send her a message and telling her that we miss her and hope for her soon recovery on behalf of the whole conference, actually. But when Teresa couldn't come, Elisabeth immediately said that I'll take the whole show. And I've read her script in 2 versions at least, and found out that Elisabeth must be one of the world's most informed persons about gender equality matters. And she will give us very, very much information today about that. So, yeah. Let's give Elisabeth a warm hand.
Well, thank you so much for inviting me here. I'm really honored. And thank you, the organizing committee. Thank you, the organizing committee. And of course, the Technical University for providing such marvelous venue and for making this conference possible. So as you see, my title might be a little bit challenging, but this is a reason. I want to start with the model of science knowledge making that was proposed by Thomas Kuhn in 1962. To me, it captures what has happened to gender issues in science in the last 15 years. Until Eaton and FP5, the normal science was gender-neutral science. This was the paradigm that everybody accepted without a question. And then a drift appeared because it was demonstrated through research evidence that women's chances of success in science careers were far worse than men's. And follow that was a crisis because research started demonstrating that there was a widespread gender bias in the knowledge, and such that it produced research that would producing outcomes that were better for men than for women. And then there was a link made between the gender equality and the quality of research. And at that point, I think we had a revolution. Because after the first Gender Summit, nearly 5,000 people signed a manifesto for gender action to act on the gender dimension in research and innovation. That was really revolution in terms of gender issues. And so all this kind of helped to inform the Horizon 2020. And I think now we are in the paradigm change phase. But this paradigm is not going to happen by itself, because the gender-neutral assumption is so deeply embedded in the science mentality and in the knowledge that we really have to keep on saying all the time that it has to be changed, because it's all about quality of science that we're talking about. So let me start with Teresa would have come in, and this is about this figure that we all know very well. It is the shorthand indicator of gender inequality in science. Yes? And what is really depressing looking at this figure is how very little has changed in the last 15 years. Okay? And on this rate of progress, by the time Horizon 2020 will finish, we might see 22% of women professors. Now, I just don't think that Horizon 2020, that has got 80 billion euros of a budget, cannot deliver some real change. And I think we should expect real change, okay? Because we know so much more than we used to know during the FP5 and FP6 and even FP7. So one thing we really know for sure now is that implicit gender bias acts at every step of the career progression ladder. And it acts in ways that have been demonstrated very eloquently by a project at the Yale University led by Joe Handelsman. It showed that both women and men professors preferred to employ a man than an identically qualified woman. Not only this, they were prepared to pay the man $4,000 more and give him extra mentoring support. So this, in a nutshell, is the problem. Even though scientists are trained to be rational and objective, they are as prone to making subjective judgments as the rest of the population. And Michel Lamont, who studies how peer review committees work, observed in his studies of many, many committees that evaluators often favor their own type of research, and what defines excellence is contingent on the cultural environment in which they are located. So we are talking about all these things because it's not women's issues, it is a knowledge issue. The Wikipedia lists 150 categories of cognitive bias. Clearly, people in general find being objective and rational difficult, and so we cannot expect and take it for granted that scientists are not free from cognitive bias. To mitigate negative consequences of cognitive bias, research needs diversity. It needs diversity in a research perspective, in research problem solving, and in ideas. Because the outcome from the research process does depend who is in the room. And a good example of this comes from the software recognition. When the first products, software recognition products, appeared on the market, they worked well for men and they didn't work for women. They were designed in acoustic labs that were populated by men. They were tested on men. They did not include recognition of women's frequencies, voice frequencies. Doesn't matter how long women spent trying to train that software, it did not work for them as well as it did for men unless they dropped their voice. So it does depend who is in the room. And Kevin Dunbar, who observes how people work in the labs, looked for differences between women and men and concluded there are no differences when everything goes to plan. But when experiments go wrong, then the differences appear. Women try to dig quite deep, trying to understand what went wrong, and men start looking for new ways, new methodologies in order to get the results that they wanted. So neither is a bad or a good strategy. What it means, we need both strategies. Yes. And Anita Woolley, who studies the relationship between team diversity and performance, has observed that the collective intelligence of a team is strongly correlated to the gender balance on the team. So what is the explanation? Yes, clearly women are not more clever than men. It is because the explanation is that women are more sensitive to communication cues. And so if you have a group of people around the table and nobody is allowed to dominate the discussion with one idea, you get a much more consensus and more collaborative problem solving. So from this kind of a research, we know that it matters that women should be participating on an equal basis with men in science. But what science really cherishes more than anything else is excellence. You hear this word all the time, and nobody defines it. It is something that has to be assessed by others, like beauty. And this is a problem for women, because even in female-friendly cultures like Norway, women also find it very hard to trust themselves that they are excellent. So Cartwright, who has transformed the situation at Tromsø University by doubling the number of women professors in the last 4 years, he introduced a scheme where a panel of external evaluators were invited to look and talk to women the university felt were ready to advance to the full professor position, but were not putting themselves forward for these opportunities. So the panel looked at all sorts of criteria that the university accepted and said, yes, they were ready, but they didn't think they were ready. So this is a very interesting thing to keep in mind. So what is going on? And one explanation may be, but it has not yet been studied, is the woman's attitude to risk. James Burns studies people's attitudes to risks and did quite a large meta-analysis study. And he found on a number of types of risks, there were no differences. Smoking, driving, that sort of stuff. But in 2 categories of risk, there were big differences. One is physical risk, i.e. bungee jumping, and another one was intellectual risk. There were big differences between women and men. And so it was interesting that he observed that men were taking risks even when it was wise not to take a risk, and women were not taking a risk even if it was wise to take a risk, like taking a test exam. So this kind of tells us that we have to tell women that they have learned behaviors, risk-avoiding behaviors that are really stand then against them. It might be one of the reasons why fewer women than men apply for research grants, for example. So the problem is that this kind of a doubt, self-doubt about your abilities starts quite early, and the cultures in which women find themselves do not help. So here's a figure that shows quite strikingly how women's attitudes and belief that they can pursue a career in science deteriorate over a 3-year period. This is a survey that was done by the Royal Society of Chemistry and Institute of Physics in the UK. In the first year, 72% of women wanted to continue with the research career. In the 3rd year, only 37%. They have given all sorts of reasons why. Of course, family and work-life balance is there, but it's not the primary reason. The primary reasons have to do with the cultures in which those women found themselves. So one thing that a lot of people don't understand until it's quite late in the career is that science career is not a job. You are employed by a university and they pay your salary. You are expected to contribute to the knowledge, and you are also expected to contribute to the community. And you are assessed at every point. This does not happen in any other job. And how you manage these three things is very important, because if you focus on one thing, like contributing to the publications, then of course it will be slightly different than if you want to be a very good citizen and do all the stuff that your university expects you to do. And women are not told that. And so they kind of want to be willing to be good and might be punished. The other thing that interests me quite a lot lately is the HR methods that are being increasingly used in universities as universities became more independent and more commercially orientated. So one thing that universities are increasingly putting in place is HR people management methods that have been developed for commercial world, for industry. One of them is Hay job evaluation system. The Hay job evaluation system was developed in the US in 1950s. It was to help manufacturers reward jobs. So if you were on an assembly line or if you were a manager, you were supposed to get a pay that rewarded you for the work you have done. This was not designed for universities. This was not designed for science careers. This was not designed to represent this triple kind of responsibilities of science careers. And the most important thing is that the Hay system, and there are similar ones like that, they're not all called Hay systems, divides jobs into pathways. And once you get into one pathway, you can only progress in that pathway. So you cannot cross over. And this is really important, because it means, okay, in a commercial world, if you have started in sales, and that's public-facing functions that men think women are very good at, you cannot go to research, okay, even if you have a PhD in physics. So in a university, it means that where you start is very important. It will determine how much you are paid, which kind of a networks you're going to connect with, how you're going to progress, and so on. And we don't know that, because, of course, all the organizations want to be transparent. And in a sense, the Hay system or similar provide transparency, but the Hay system and the other have been criticized for being gender biased on the basis that they overvalue high management roles. And as we know, who is in top at the universities? 80% of men. So it reflects the views of the people who are at the top. So there is more than one way to excellence. However, it is the stereotyped career path that determines what we think is excellence. In a just completed study that was funded by European Research Council, Clarty-Winkenberg analyzed career pathways of the ERC grantees. She found that there were quite a lot of diversity, not surprising. And she described these patterns in terms of dance routines. There was a waltz, a slow waltz, a foxtrot, a quick step, and a tango. Each is good in itself. However, although there are many paths to excellence, it was the conventional career that was rewarded. So the evaluators expected the conventional career pattern. And you can see on the left that thing in blue, a typical conventional career pattern, and this one is for Germany and was devised by Leroux. So just to exemplify this difference, I'm sure you all know the woman at the top. It's Nancy Hopkins. She's an excellent scientist, but she's also the person who has transformed cultures at MIT to make them women-friendly. In fact, when she started, she wanted to have a lab of her own, and the university was putting barriers for her to do it. So she got a group of other women scientists, and they went to and measured everybody's labs, and they found out that men had bigger labs, better equipped labs, And that was the start of a change at the MIT, which continued. So that I met Nancy about 3 years ago, and we realized that there was something we had in common. We both started at the same time about life sciences. We both had mentors who were DNA discovery team, yes? So hers was James Watson at the MIT, and mine was Maurice Wilkins at the King's College London. So what happened was, in our careers, Watson pushed Nancy towards being a proper scientist. So she became a proper scientist and an excellent scientist. Wilkins introduced me to social responsibility of science, which was something that he really, at the time, was very, he even started a course on that. And so my career pathway was more of a twist, and her was the real waltz. So the lesson from this is that a career can be shaped by many things. And I think when young women start on a career in science, they really need more than one role model and more than one mentor. So you can actually make your own kind of a choices, what is right for you. But the thing that I want to really stress here is that this conventional career pathway favors men. That is, men have more chances of getting on that pathway than women. And the reason is that when research teams are formed, that is when you are about at your PhD and postdoc level, there is a gender bias in the way people are selected for teams. And this figure, this table shows it. On the left, you see the comparison between the males and females on ERC's projects. And on the right is the supply of men and women in Europe's universities at the same levels of seniority. What you will see there is that at each level, until principal investigator level, there are more men selected to research teams than women. So this is really interesting because ERC grants are given to individuals. So it is individuals, women and men, who make those choices. And here's another look at the same situation. So these are, again, ERC team members by field. And what you see in the life sciences, which is the thing on the left, and social sciences and humanities, which is the thing on the right, that in all cases, women are disadvantaged when teams are formed. Okay? This is not something that the research funders have considered. But they have the power to make sure that when research teams are formed, that we have a gender equality in there as well. It gets a little bit worse. Because here, so I have already mentioned 3 areas of bias that stands against women's success in their careers. One is, of course, the implicit gender bias. Then is the cultural environment bias, that is pretty much male-orientated, and then is the conventional career bias. And those 3 things combine when research funding is allocated. And this figure demonstrates for European Research Council. You can see that men are systematically more successful in getting a grant than women. And this success accumulates over your career. So if each time you apply, you have a 6% higher chance of getting a grant than a woman, then by the time you are in your senior position, you have had quite a lot of advantage. So not many research funders publish this information like this, but I have seen data for United Kingdom and some for Germany, and I think it would be fair to say that this pattern persists in other countries as well, in other funders. So the other interesting thing to point out here is that ERC did look at the gender balance of the evaluation committees to see if it made any difference to the success rates. It didn't. Okay, so that confirms the results from the Yale study, We are biased, we just have to admit this. So what are women to do if they want to have a career in science? When men go to war, there seems to be no question that women have the ability to do men's jobs. But in peace, the society becomes ambivalent. They encourage women to pursue higher education. They allow women to participate in the labor market, but women don't have the same right as men to pursue their career aspirations. So there is a quick fix to this ambivalence, and it's called gender quotas. But do you notice how the design of their pushchairs for babies has changed ever since men started taking parenting duties? So the best reason and justification to promote gender quotas is the fact that it is the quickest way to change the cultural environment for women and for men. And the reason is that gender is one of the most biologically primitive and important social categories. It is the first social category humans are able to discriminate at as early as 9 months of age. Gender-related stereotypes are among the first stereotypes we create in our minds, as early as age 2. So you can see why women and men professors might favor men, because in their heads, from the age of 9 months, that particular reason is already there. But the problem is that we see women and men as complementary, so that it's different to other contrasting categories like white and black ethnic groups. And this complementarity promotes inequality by saying that basically our roles are fair and basically that's the way the world is. So now I come to the real reason, and probably the strongest reason that the science could be encouraged to take gender equality issues seriously. And this is the fact that the gender inequality in participation and the gender-neutral science assumption in science knowledge making affect every step of the research process because people are doing it, yes? And people's thinking and people's problem solving influence what questions are chosen and what data are selected and how it's analyzed and interpreted. And the problem is that the research standards are gender blind. In key areas, for example, such as stem cells, ionizing radiation, toxicity, animal models, the current standards leave out almost completely discussions of the role of sex-gender differences as the variables that have to be examined. So we have a bias in the knowledge and bias in the literature. In 2007, the journal Pain noted that 79% of the studies it has published in the preceding 10 years used male animals only. And in 2013, American Journal of Physiology published a paper showing that 75% of studies it published on cells did not specify the sex of the cell. So this is now being realized, fortunately, and the NIH and United States has announced early this year that they are changing the policy. They are going to require that all applicants state how they're going to account for sex of the cells, and they are expected to use male and female cells unless there's a really good reasons why one or the other has to be used. So I'll just give you a few reasons why this is so important. Okay, so these tables, which you probably can't read at any case, they show comparisons of the effects of drugs in humans and in rats, and compares the male and the female. In both cases, there are big differences. Okay, so the drugs stay longer and are processed more slowly in women. And that means that maybe women should have less of the dose of the drugs. I read one paper that says in anesthesia, the difference could be as much as 30 or 40% of the less of the anesthetic that the woman should receive. And so we have these issues. So we know that there are differences, but there is another problem here. The problem is that the animal model, which is the rat in this case, has been used and has been popular because the sex differences are very pronounced. So it seems like a good way to study it. However, someone has pointed out that these differences might be the result of the inbreeding of the rat model. So the rat model, not only that it's predominantly male rat model, but also this rat model might not actually translate to the human beings. So this selection, the selection of our, what information we start with is very important. This stuff is embedded in the knowledge. So if you begin your research process and you're at the beginning and you're looking for background literature and so on, you just have to be aware of the bias in the knowledge. So here we have the tendency in the past on the left of people choosing the most convenient subjects that were available, and it's usually students in medical schools, young, healthy males, who are then kind of representing the rest of the population. And here on the right is a comparison between the prevalence of diseases in women and the number of female animals that are being used in preclinical studies. So you can see the difference between the green and the purple, that there is a big underrepresentation. So that is, the women are not properly represented as targets in the questions that people ask. And this imbalance just persists. In most studies related to diseases, when women are included in studies, they are hardly ever in percentages higher than 35%. And in cancer studies that are not related to sex, 70% of studies underrepresented women. So what it basically says is that science has got much more evidence for men, and so we shouldn't really be surprised that the outcomes are worse for women. And this is an interesting figure. It shows the response in a reaction to the yellow fever virus vaccination. And on the left is the females, and on the right are males. And maybe it doesn't show very clearly, but the pathways for women are much more complicated. There is much more going on when women have given vaccination in their bodies than it goes in men's bodies. So the problem is that science has assumed that this is to do with this gender-neutral assumption, is basically that the sexes don't differ. And when you assume that sexes don't differ in terms of effects, then it affects how we understand, the process of disease. And we do not understand the differences in the immunology of women as much as we understand in men. And 80% of patients with autoimmune diseases are women. And yet nobody asks why. Subracline studies efficacy of vaccines. And she has pointed out and demonstrated in many studies that have simply not reported whether they were women or men, put all the data together because then the results looked more interesting. But when she separated the results in the meta-analysis, she thought she actually demonstrated that the effects on women were different to the effects on men. And that has got impact on our health policies, because it means you have to give women less of the vaccine, and you might actually want to vaccinate mothers first, and so on. So here's another interesting situation. I don't know if you know, the spontaneous cancers are more common in men worldwide. This is just a phenomenon. But incidence of cancers following radiation are more common in women. In fact, 50% higher. And I'm sure every time you go to the dentist, you get an X-ray, and every time you go for a checkup, someone will suggest you have some kind of ionizing radiation checkup. Don't, really, because nearly billions, literally billions such tests are performed unnecessarily every year. Okay? The average annual exposure to radiation in the US has increased by 75% between 1982 and 2006. So the same must have happened around the world. 48% is due to medical interventions. So the problem here is that we just don't know how to measure the dosage. The dosage that is measured on using standards that were developed in 50 years ago, i.e. before the increase in radiation. And it's something called, one of the standards is called reference man. And reference man is basically based on a 20 to 30-year-old white or Caucasian man. Reference man is what it's used to calculate dosage, safe dosage of radiation. So reference man represents every member of the public, every woman, every ethnicity, every child, every man, regardless if he had children or not. This is a real big concern. And one thing that we do know is, of course, that the men's and women's bodies are different. And scientists have tried to understand this because that might be a quick way of finding out susceptibility to various diseases. And it is true, sex differences in body shape appear to be determined by complex interplays between genetic and hormonal factors. But one particular measurement that has been stood out in the latest study, and is the ratio between the waist and hip. And it has been linked to genetic factors. And has been linked in particularly to metabolic pathways and type 2 diabetes in women. So what you see here, the first figure is a study from NATO. They measured women and men, and in order to provide them with the right gear. And then on the two individuals on the top right, they just demonstrations of this pear-shaped males and apple-shaped male and a pear-shaped female. The difference, the important difference there is that men's fat is on the inside and women's fat is on the outside. And it's better to have it on the outside than on the inside. And on the bottom left is a figure that shows concentrations of 130 metabolites that have been studied in women and men. And it found out that out of these 130 metabolites, 100 appear in different concentrations between women and men. And so if you want to design biomarkers that will tell you whether you're likely to get diabetes or Alzheimer's or some other disease that it's linked to metabolism, you better get the right biomarkers. And on the right is just the figure that shows the green thing in the middle, which is for men, just shows that there has not been that many connections between the metabolism and genetic disorders, genetic factors, but the pink one was for women. So that is this link between metabolic pathways and metabolic diseases in women. So women are actually very interesting creatures to study. And on the left here, you see two comparison between the X chromosomes in a mouse and in a human. So what happened is, up till very recently, the dogma has been that if there are any differences between women and men, it must be hormones. It's not true. it has other things as well. Hormones, of course, are there, but a number of studies have showed that the differences occur long before hormones even kick in. And one thing that the differences determine is how cells die. And of course, if we know how cells die, we can stop them dying, and so on. So these are important things. So when it was realized that maybe hormones are not the only thing, people focused on the sex chromosomes. And of course, women have 2 X chromosomes, men have only 1. And so women, in theory, would have like a double dose of X genes, but nature has found a way to deal with this, and one of the X chromosomes, either the paternal or the maternal, is shut down randomly, not completely randomly, but more or less randomly. So in my body, half of my X chromosomes come from my father and half from my mother. It means half of my cells have a slightly different X expressions than other half. And that protects women in many diseases. Unfortunately, the second chromosome does not shut down completely. 15% of the genes on the second chromosome that's supposed to be shut down are active. And so women have an extra dose of X genes than men have. And that has been proposed would be the reason why women suffer much more from the immune diseases. However, another problem is in here, because preclinical studies are mainly done with mice. And in mice, the second X chromosome does shut down. And so again, we have an issue for translation, because we don't really know whether the data that we get from mice actually represent human females. The other reason that women are so interesting to study, and I don't know why men have ignored that fact, is that there's this process of microchimerism. So it occurs when you are pregnant, and your body and the baby exchange cells. So your baby will have some of your cells, and you will definitely get your fetal cells. And those cells persist in a female's bodies for a long time, especially in bone marrow, in heart, and so on. And have been suggested that would be another reason why women suffer much more from autoimmune disease. But then also those cells have been found in the heart tissue, and those cells are primarily stem cells. And it's now thought that that may be also one reason why there's a protective mechanism that women have that is for heart failure. It's a good idea. Okay. So now I want to get to the issue of the Horizon 2020. In the Horizon 2020 program, it says that gender is relevant to the call whenever an in-depth understanding of men and women's needs, behaviors, and attitudes contributes to improve the scientific quality and societal relevance of the produced knowledge, technology, and innovation, and may lead to products that are better suited to potential markets. When I mention revolution, this is a revolution. That statement is a revolution in the thinking about gender and science. But it says that you have to demonstrate some in-depth understanding, and so you need some way of demonstrating this. Okay? So I have produced this schema. It's not perfect, but I just wanted to show that you cannot ignore the fact that sex and gender and environment work together. They either reinforce each other or they fight each other. Okay? And this has to be considered when we write proposals to Horizon 2020. So here's an example. Transport is one of those areas it's definitely in Horizon 2020, and the calls have asked to consider gender, and the things that I mentioned, it's things like behavior and so on. And so it is worth to kind of think about it quite seriously, because clearly transport is intended for human use, so gender dimension is relevant. And it is relevant because both biology and social factors and the environment, in which case here I put the transport system in a broad sense, influence the behavior of the users, and the user's behavior influence the environment as well. So, for example, men use more energy in transport than women. In Greece, 350% more. Cars were designed for men. Men used to drive, women didn't. And they were tested on male crash test dummies. There are no female crash test dummies. Cars are less safe for women than for men. Women have a greater risk of a whiplash injury than men because they have smaller bones and have less muscle around neck and the torso than men have. Women drivers have a 47% higher chance of a serious injury than men in a car crash. 3 things happen when you have a car crash. A car goes into the barrier. You go inside into the car. Your brain goes into the inside of your scalp. So because women are smaller and structured differently, and there are no female crash test dummies, the risk for women is much greater. Women use public transport differently than men, and public transport often ignores, if not always ignores, the basic requirement that women have. When my children were small and I had this pushchair and I had to get up and down, 3 flights of stairs because there was not a lift and nobody would give me a seat on the train, I felt pretty angry. So public transport has to recognize that there's people who use it, old people, young people, have different needs. Women make lots of little trips, men make fewer trips, but much bigger trips. And women are affected by traffic pollution in a different way than men. And yet nearly everything we know about toxicology and impact of environmental pollution is based on what we know for men, not for women. Food security and safety is another big issue for Horizon 2020. And here sex and gender and environment come up in a really very interesting, many different ways. The majority of our food supply is a product of sexual reproduction. Therefore, understanding the underlying processes in animals and in plants will help us manage future food production. Each day, more than 150 million chickens are hatched in the United States alone. If you are an egg producer, you don't want male chickens, you want female chickens, okay? But the checking of the sexing of the birds is really very difficult. It has to be done manually. There's just not enough people to do it. So some kind of efficient technology that can do this would be really welcome. Birds are also very interested things for developmental biologists to study, because the fetus developed outside the female body. So it develops in the egg. So you don't have the interference of the maternal environment on the fetal development. So developmental biologists like to look at birds. And then some very strange phenomena happen in birds, like this chicken on the right. It is on one side is a male, on the other side is female. On one side has got just the male cells, and on the other just the female cells. So that's a really phenomena that kind of very interesting. Maize is a very, very important crop for most people around the world, but it is a hybrid seed, which requires very intensive farming method where people have to go and detassel every 4th row in order so to avoid self-pollination between the 2 varieties of maize that you're growing. This is very costly. And Burkhard Schultz in the States has been working on using natural plants, steroids, to try to develop plants that just produce female flowers. then flowers can act as entry points for microbial and fungal attack during pollination. Understanding differences in the infection rates between male and female plants can help develop ways of promoting pathogen resistance in plants. And then, every 4 months, a new disease appears, and mainly arising in animals. 75% of new diseases originate in animals. In the developing world, women are predominantly responsible for the care of domestic animals. They are the ones who are most at risk from the zoonotic diseases. Now we have a climate change. So women have been excluded from climate change debate for ages. But sex and gender environment combine here as well. The current models of Earth's climate capture the planet's physical and biophysical processes. But the planet has entered a new state. Humans are adapting to climate change. Women and men might adapt in a different way. And humans are affecting the climate change also. So we need a more realistic models which include the human behavior feedback. For instance, in the developing world, 95% of cooking is done with biomass fuels. Women are responsible for gathering this fuel. They are responsible for cooking. They are also the ones who inhale all the pollution. Another aspect of is biodiversity. Research in 60 home gardens in Thailand revealed 230 different species, many of which had been rescued by women from neighboring forests before they were cleared. And in a study in Sierra Leone, women could name 31 users for trees, while men named only 8. At biological level, women are less able to tolerate heat stress. They simply just don't sweat as much as men. And this might mean that they will find adaptation to climate change and high temperature harder than men and might suffer more health problems. Pregnant women are particularly vulnerable to malaria, and climate change is predicted to increase areas where malaria is going to be present. So I think you probably have enough evidence to make sure that, as I'm right, doing gender equality is right because it is going to produce better science. So let me just summarize what are the most common gender problems still that need addressing in order to improve quality. I have mentioned the implicit gender bias in academic recruitment and promotion. I have mentioned the cultural environment bias in peer review. I have suggested that we need to really look for gender bias in HR management methods. I have also said that there's a danger of this reliance on stereotype career pathway bias. There is certainly gender bias in research team formation. There is definitely gender bias in research grants. There is a sex gender bias in research process and standards, not only in the study design, because gender bias, gender blindness has been characterizing the knowledge for quite a long time. Women are excluded when discussing and addressing solutions to societal challenges. We overlook the fact that gender and sex and environment interplay, and we have to take that together. And we need someone who takes an ownership of the cross-cutting role of gender equality and gender dimension issues. It is not just about women. It is about every field in which human beings either are participants or beneficiaries of science. So why should universities take action? Well, they should take action because they receive public funding, and women are taxpayers. They don't want to fail the taxpayers. They are responsible for supply of human intellectual capital. They fail if they ignore half of the talent potential. They are responsible for broadening the minds of the young. They fail if they do not teach them how to challenge negative cultural gender attitudes. They are expected to contribute to economic and societal well-being. Well, they will fail if they ignore the fact that women are really fantastic market for science knowledge. And of course, universities believe in excellence. But that cannot be just excellence for men, it has to be excellence for women. So we have Horizon 2020, and if you have been in gender issues for so long as I have, so not as long as Teresa, you know that this is really an opportunity that we cannot let go by. And the really good thing is that gender balance in teams is a criterion of success. Gender dimension in research content is a criterion of success. There is also this innovation of introducing gender as a cross-cutting issue. However, if you look at how proposals are going to be evaluated, it's not very clear. If you look at what information is expected that people will produce in the proposal, that's not clear. It is not clear how the Commission is going to monitor and report on progress. Certainly the monitoring is not going to start till 2015. Plans for continued policy commitment after 2015 are not clear. The current work program for Horizon 2020 is only for 2014 and 2015. It is quite easy that with the new leadership at the top of the Commission and the new MEPs in the European Parliament, that somehow this advancement that has been made with Horizon 2020 now quite easily could disappear. I really don't think that we can just sit and accept that because it has been listed in Horizon 2020 now, that it will be there in 3 years' time. So we had a gender summit 2 months ago, and there were certain recommendations from the gender summit because to make sure that we don't miss this opportunity. And I must tell you that Horizon 2020 has got a budget of 80 billion. All the framework programs prior to Horizon 2020 had a budget together of about 80 billion euros. So if you think that was all that happened with this previous 80 billion was the small increase in that in percentage of women professors, you really have to be careful that this next 80 billion is spent much better. So the recommendations from the Fourth Gender Summit were that we really have to continue emphasize the positive effects of gender balance and gender dimension. And it's not only in Horizon 2020 calls, it is also in European Research Council and in their Marie Curie actions. The evaluators have to be trained on the gender criteria. They are not, and they don't know, and they don't have the knowledge that we have in this room, because that might be relevant to how proposals are ranked. We need to be very clear how gender is going to be evaluated during the assessment process. The NCPs, the applicants, the evaluators, and experts must have the same understanding what is meant. And then we have to explain in each call what information and actions are expected from the applicants. They have to be in the background, they have to be in the work packages, they have to be in the impact. They cannot be just one paragraph which says, this work is going to be relevant for gender. So that's my story. And thank you very much. You can find lots of information on those links. And please come to next Gender Summit because that's where we can, make some influence. And you can contact me on that email address. Thank you so much.
So much knowledge. And I hope no one interprets the data that Elizabeth has presented as depressive. Instead, I think we shall take the standpoint that Elizabeth herself did to make this an inspiration to us all to work for gender equality. So although Elizabeth has presented very, very much knowledge, I know that she has more. So why don't you pose questions to her? And I think there are some microphones or comments.
My name is Petra Lucht. I'm a guest professor for gender studies in engineering at the Technical University of Berlin. I'm really glad that you highlighted to what an extent the field of gender and science has come up to the European level, on the one hand. Actually, I also have a fear, and this fear is that gender differences get manifested even further with this further research. As in the past, gender differences have been left out of research. And I'm wondering to what an extent gender studies that address not only biased differences between men and women, but also gender studies that acknowledge that there are intersectional or interdependent causes for all these inequalities will be addressed. And to what an extent we will avoid to portray a family model that has been established in the 18th century in Europe to all over the world. I really don't want to engage in that endeavor. And that is a fear we've discussed, and I'd like to know how that will be prevented or avoided. Thank you.
Well, it's a very fair question. And I completely admit that we at Porsche have been really concentrated on women and men as the two biggest categories that there are in the world. And when I go to America and when we had the Gender Summit in Washington, it became apparent that one group that we have been not thinking about was the ethnic groups. And the session was included about the role of black women in science. I must say, because I live in London and because London is such a diverse place, these thoughts haven't really been on our priority list. We've been really trying to fight the fact of understanding women and men as participants in the research process and also as beneficiaries of science knowledge. But I completely acknowledge and admit that we have to go beyond that. But it just has been so very hard just really to persuade scientists to just look at women as worth subjects of research, that I just feel if we start at this stage diluting the message by saying, by the way, there are all those other categories you have to also think about, I think we will lose their interest. At the moment, we feel that there's the evidence that, I know it goes chromosome upwards, so 2X to Y, XY, and that doesn't apply to everybody because just X and another X is missing. It's not the same as having the second X shut down. So there are all sorts of issues, very interesting issues that are there. But I think at this stage we just feel like we are in the process of trying to force the thinking in science to go beyond this male as the norm thinking. And then we can move further. So I'm sorry, I apologize if we're missing out on other groups, but I think we're just kind of going along our own paradigm in here. I think I have
questions.
Okay, you're obviously very hungry.
Bente Knoll. I'm a self-employed landscape planner, gender expert, as well as a lecturer at various technical universities. My question is, you mentioned some recommendations what to do to improve the gender competence of evaluators, members from NCP and so on. Could you give us some insight? How could that be put into practice? What would be your recommendation to improve the gender awareness and gender competence of these, well, civil servants and people deciding for the Horizon 2020?
Well, look at this room. I mean, we have so much expertise in this room. You know, we could actually get together and advise the Commission how the criteria and the process of evaluation should be done in order to make it fair. So the evaluators and their NCPs and so on know that when the call states and gender should be also considered, which is what happens now, without actually specifying in which bit of the call it is relevant to, and I have read all 120 of those calls that mention gender, it is just not enough to mention and gender also should be considered. No, gender should be stated that gender is the variables that it's really being considered in depth because it matters for those reasons. So basically one thing has to be said is it is not enough for you to put a paragraph to say that you have looked at gender and include 3 or 4 references. No, it has to be integrated. But it's not for me to say. I have been once on the evaluation process, so I kind of know how it works. And it can be pretty random at some points, and that's why I think it needs clarity. And I think, maybe it was suggested briefly that maybe one thing from this conference could be some way of producing advice to the European Commission how the NCPs and the applicants and the evaluators can have some kind of a systematic guideline that says you have to look at what has been said in the background for the proposal, and your objectives. Does it link to the task listed in work packages? Does it actually mention how it's going, what happens to the impact? How does it link to anything else that the Commission might have been doing? It shouldn't be very difficult, and I think we could all do it if we want to.
My name is Margaret Maurer, and I was one of the pioneers of gender studies in biology in Germany and Austria, and I'm now teaching at the University of Linz, teaching engineer students. I have 2 questions about the evaluators in the programs of the Commission, because I was an evaluator in the 5th program. Now, at that time, it was really absolutely hard to even comment any gender issues. So my question is, do you see a change in the sensitivity among the evaluators, in respect to the selection of evaluators, and how would you like to, how can you ever do a training of evaluators? I remember some very strong male colleagues there from Greece or from Spain. I can't imagine how to train them. So it would be very interesting to know how you do it. And the second thing is that I really have to confess that I feel a bit I felt a bit down when I heard all your wonderful data. I mean, it's really I liked it very much that you got through all the steps of research showing the gender bias everywhere. But I have to say that in Germany and Austria, we had some autonomous non-universitarian meetings of students and professionals in science and engineering. And we always discussed one problem. When we teach such data to our students, then there is the danger that the female students get demotivated because of all the barriers they have to expect in the future. This, yes, and we have no data about if this happens or not, but it was a very sensitive point, and I think after your presentation, I think it's still a point, because we do want to encourage the female students. And of course, I do not see a real good solution, because it's important to present such data. But I think perhaps it's better to begin with best practices, how to overcome all these biases, etc. It's only just one spontaneous idea.
I think both are needed, because the best practices, we've been working for ages to make a change, and there are good practices around. So I think they have to be just adopted more widely. But I think it's better to open women's eyes to the reality of the situation. They're clever enough, they will be able to deal with it, rather than kind of disguise it by, you're going to be recognized, you just have to work hard, and it's the science is fair, and so on. I think women should be perfectly aware the reality of the situation. And the other thing is that, I think it is really very interesting stuff, because the more you look into this evidence, the more exciting actually the research can be, because you look at the areas where you have to decide when does it matter, when differences matter, but they don't matter. But they don't have to matter all the time, and we need to know when they don't matter. But when they do matter, let's do something about it. This is a new way of doing research. This is opening new markets for science knowledge. This is making society feel that they're investing in science that is actually fair to women and men in society. I think the message has to be that this is really good for science. I think young women will be able to deal with the fact that the data shows that they have not really been as subjects, they have not been there as research participants, not as subjects and not as targets for research. But they can change the world. That's okay. They just need to know that. Unfortunately, they don't know it.
My name is Karina Kana, and I'm a PhD student in physics. And I have more of a comment to what you said before about not thinking about other ethnical groups in our policy making. And I have to say I really disagree. I strongly disagree. Because it's everything is interconnected, yeah? And everything is put together, and we have to think about all these dimensions. We have to think about the dimensions of ethnicity. Because when I go to a conference, and I've been to many conferences, and I've never seen a black physicist woman. I've seen one black physicist man, that's another issue. But so it's so important, because we are excluding basically one group that's also in a social dimension from a different also there is a social dimension in that ethnicity issue that we are not planning in. Also the social dimension that also includes other it also includes white women in the sense of middle class, lower class, working class. So this is all connected. So I have to say I really disagree, and we should think about how we could include everything and every concept we can think of. Thank you.
Completely fair enough. I'm not at all disagreeing with it. What I'm just saying is who should be responsible for it, okay? The things that you mention the science would say that other people are responsible for equality. There are equality laws. There are legislation. Should science worry about all these divisions, yes? Or should science only worry about what science is about, which is producing knowledge that is excellent, okay? So the way I'm justified this for myself, okay, is that science or scientists will respond to research evidence. The only way that we have managed to progress that far and to have 4th Gender Summit is because of the research evidence, not because of strength of the social justice arguments. Science will quite easily shrug off social justice. It's nothing to do with science, scientific excellence. It's about legislation and societal issues and so on. And I think it's very important not to mix the responsibilities. If we want scientists to be part of the gender equality actions, they will respond to research evidence. If you put the research evidence in front of them and it says, you think you're doing excellent science, I can show you that you are not, in which case you can say I'm stupid, but show me evidence that I am stupid, yes? If I go to, and believe me, it's hard to try to persuade leadership, scientific leadership, that they should seriously look at this, because everybody will subscribe to the social justice argument. Yes, of course, we believe, yes, of course, this is right. Where is the research evidence that shows that this actually affects the quality of science? So if you have any research evidence that can support those beliefs that you have, please let me know. I am very happy to add slides into my thing that will say, and by the way, it's not just women and men, but also science will be much better if it does the other things. So the only way I find you can persuade scientists is through research evidence, and the fact that you can demonstrate to them that they are not as excellent as they think they are. Okay, so it's an ongoing process.
And I will pass it to my colleague here to continue on this very issue. You have shown us clear evidence that research applications coming from women are not very successful compared with the ones coming from men. What is done about the committees, the panels, the referee panels who are looking at the research grant? Why is the gender not considered when the panel is formed? So if it's a whole male panel, obviously this bias will continue to exist and they will select mainly male application. Is there anything you could help with in this aspect?
Okay, so first to defend European Research Council, they actually care. They actually are looking at the data and they're actually trying to understand what's going on. But not all research councils are doing that. They looked at the gender balance on their committees, and basically that didn't make any difference. So the solution has to be, and the reason has to be, is that we are all brought up in the societal, cultural environment that says men are better than women, and the scientific environment that continuously seems to be rewarding men. And so, and obviously women and men, doesn't matter if you have a just men or just women or imbalanced committee. I think that the only way to really deal with this now is through training. You have to train the evaluators. And in the UK, the Natural and Environmental Research Council has started this year training the evaluation panels on implicit gender bias. And in the States, big companies that have diversity, I think like programs, have now started training their management on implicit gender bias. So because we cannot rely on scientists, men or women, that they are going to be objective, we have to really produce some kind of guidelines and a training so they can recognize where bias occurs and where they can be. I think everybody in this room knows about Brian Nozick's study of the implicit gender bias. 70%, that is a test you can take on the web, 70% of people worldwide, and we're talking here nearly 1 million people, associate being a scientist with being a man. Okay? So I think the only way that research councils can become fair if they tell the evaluation panels, show them this figure and say, why is it that men have been getting more grants? Okay? Obviously, even we're trying to have a very good processes, the processes don't work, yes? And I think that has to be that process of awareness and training, and research councils have to take that responsibility.
Thank you very much for the wonderful presentation. My name is Sister Margaret from Gulu University in Uganda, northern Uganda. I'm privileged to be here, and I would wish to inquire from you if there is a possibility of linkages of these universities with African universities, particularly in the promotion of gender equality. I am a PhD candidate of Gulu University, and this is a university dominated by male staff. On the top management of 10 members, I am the only female, and it's very difficult to promote gender equality working alone. Could there be some exchange programs between some of these universities and Gulu University as a way of promoting gender equality and encouraging female students to take up higher education? Thank you.
Thank you for this question. What I want to tell you is that in end of April next year, there's going to be Gender Summit in South Africa, in Cape Town, because we recognize that different countries, different regions have a different issues, different histories, different traditions, and so on. And this promotion of this gender equality related to research and to innovation has to recognize the specific regional differences. So give me your card and come to Cape Town. And definitely this is something that could be one of the outcomes from that summit, is to find some sensible, feasible ways of helping organizations in Africa to develop their own. Thing is that everybody has to develop stuff that will work for them. You know, we here in the west of Europe have been working on it for a long time, and we are kind of pretty deeply embedded in all the arguments. But these are not the same arguments that can be extended in other regions, and I am very, very conscious of that fact. So let's talk.
Okay, one more question. Then the time police is tracking us.
Hi, UD Archibong from the University of Bradford. Mine is a plea, and it's to do with the other comments that has been made about how we can travel on this journey together. I really want to disagree that we don't have enough evidence to show that there is racism in the world of science. But what will work is if we can actually travel with a more intersectional approach and use it as a strength to push the argument. And that has to show in the way we actually conduct business. So in effect, we do know that there's been false research which shows that black people have small brains. That automatically shows that black people are not excellent. And we know this all over. So I wouldn't want us to travel with the argument of lack of evidence. What would be useful is actually how do we promote strength in what we're doing by looking at intersectionality. So what other principles within the work we're doing as women can help us push the agenda? So for example, I've said this before to you, Elizabeth, about how we actually look at gender beyond the traditional binary gender definitions to include other forms of gender identity. And let's, within us, actually look at those strengths that we can pull together. Nobody's going to help us pull those strengths. So then we begin to ask ourselves questions. When we are setting up advisory boards to run our own gender conferences, what representativeness are we considering? Are we looking at generic gender identities? Are we looking at blackness as a contribution? So we are the ones actually pushing the intersectionality. And let's get away from the evidence, because we have enough evidence to show that science is embodied beyond just men and women. Thank you. It's a plea. Not a question, it's a plea. Let's work together.
I welcome all this, and these points have been made. These points have been made at the last Gender Summit as well. No, we take this on. I mean, believe me, I'm not ignoring it. It's just I am kind of going along the arguments that we have used so far. Yeah, but it doesn't mean that the arguments should not develop in the future.
So, although hungry for food, we are well fed of knowledge. So I think that we should thank Elizabeth again for a very nice presentation.